So good morning, everyone. Welcome. I'm Christina Rogopoulos from Sila Solutions Group, and I just want to thank everyone for joining us for the Identity Management for the 21st Century IT Mission webinar. Just so you know, there will be a recorded version available after the webinar, and slides will be sent around by tomorrow morning. And we're also taking questions throughout, so if you have any questions, please type them in the Q&A box on the right-hand corner of your screen. So we're first going to get started with Paul Grassi. He's the VP of Federal Programs at Sila Solutions Group, and he's going to be kicking things off.
Thanks, Christina. Like Christina mentioned, we're going to try to take all these questions at the end, but if we see something that pops up that we will try to answer, we will do that. But for the most part, we'll keep questions at the end. Not to show any biases, but it seems that Mac users won't be able to view this in the high quality that Windows users will get. We noticed some discrepancies on the Macintosh side, so if you're using an Apple to view this, we apologize in advance for some of the graphic errors. If you have a chance to switch over to a Windows PC or a non-Safari based version, that would help. So today we're going to talk about pretty much what the challenges that we're facing in the information security and identity management information sharing landscape. For those of you that were at the event that we held in Washington, D.C., this is going to be somewhat of a review, so I will try to go through these things as quickly as possible while providing those that weren't there a solid foundation. We really want to get to the meat of this presentation, which is the vendor discussions and the applicability of these technologies across a wide set of use cases. We'll spend a little time talking about the evolution of access control, what we think the framework is for applying an attribute-based access control model to your identity management mission, and then we'll drive into the use cases and the vendor overviews. So how did we get here, and what are today's challenges? For those of you that are familiar in the federal space and those that have been following things like the National Strategy for Trusted Identities in cyberspace, we've done an amazing job industry-wide establishing strong authentication to sensitive systems. We've established trust frameworks. We've extended strong authentication to a variety of mobile platforms, and we've really done a very good job protecting the door. However, once you get through that door, you are posed with a series of frustrating, convoluted, confusing processes to really get access to the systems and information that you need. Sometimes that's compounded with the fact that some organizations, once you're through the front door, you're into everything, and we've seen some high-profile media coverage of examples of that. So what does this lead to? You got frustrated users, you've got the inability to provide information when it's required, you're spending a lot of time and money trying to get access, and in a lot of cases, you ultimately don't get the information you need. So as a result, we have one of many scenarios that could occur in today's enterprise. On the legitimate side, doors are open that should be open, doors are closed that should be closed. However, more often than not, doors that shouldn't be opened are opened, doors that should be opened are not opened, and we've got a disaster waiting to happen. So how did we get here? We have been trying to solve authorization problems with legacy solutions. We made authorization a IT solution, not a business solution. We got bogged down with stovepipes, multiple policies, and poorly defined infrastructure. And as I discussed, we focused on the door, not the data. However, as I mentioned earlier, we have done some great things to bring identity management to the forefront of mission. We've done some great things establishing a common set of frameworks and policies and standards around identity. And examples of that include NSTIC, the Identity Ecosystem Steering Group. NIST, the National Institute for Standards and Technology, has issued a draft on ABAC. While it's federally focused, those in the commercial world can find broad applicability to their problems. And then we've got trust frameworks that are industry focused. Safe Biopharma is an example I use, but we've got multiple across common communities of interest. Next slide. So real quick refresher, the access control of the past was primarily based on ACLs. We matured and went to kind of a role-based model or a group-based model, all of which were very difficult to manage, very localized, and it requires object owners to know in advance about their users. And it's that knowledge in advance of users which makes it tough to predict who really needs access to what and when they need it. Enterprise role-based access control, while not a scientifically approved access control model, is industry's solution to abstracting these three models into something more enterprise-centric, more business-friendly. We can encapsulate any or all of these models into an enterprise role and do provisioning that way, but again, it still requires that upfront knowledge of people assigned to objects to make that work. So we're calling that a legacy problem, a legacy solution. Then we introduce attribute-based access control. It's fine-grained, it's attribute-driven, it still requires local policy to be set. It could be proprietary enforcement. It's very technical in nature. And then finally, we introduce the notion of policy-based access control. And while NIST doesn't necessarily define policy-based, what we think differentiates PBAC from ABAC is that it's reusable, it's context-aware, it's externalized from the local system, it's standards-based, it provides the ability for business folks to participate in the definition of access control policy, and it's not technical. And that's where we see future-proofing our authorization capability for next-generation systems. Now, before we get onto this slide, the issue with ABAC, which is also one of its benefits, is the local object administrator, who typically would provide access control, is starting to lose that control, starting to lose that power. As we push authorization decisions down to the attributes, based on attributes of an identity, we're really putting that authorization control into the authoritative source owner, not the object owner. So there is a little bit of a paradigm shift that we need to accommodate organizationally that you're not going to find is solved with just technology, and we'll get into some of that in a little bit. So what do we see as the building blocks? You know, I'll look at some of the analysts' work that's been done. There's some technology vendors that are kind of trademarking some terms around, you know, identity is really the next firewall. The keys that you carry with you, the attributes that you carry with you, really are what's going to harden our data or expose our data, not the traditional network-based authorization that we're used to. So what are the elements that we see are required? They are federated identity. We are in a diverse, distributed environment. We are not dealing with identities that we solely control anymore. In fact, federated identity, while it was established for good business purposes, once you federate that identity, we tend to go back to the old-fashioned way of providing authorization, and we've really diminished any benefits of the federated SSO transaction that we were looking for. What do I mean by that? We may federate, authenticate an individual with a standards-based technology, but as soon as they require access to a system, we devolve into batch processes, we devolve into complex workflows, we devolve into manual processes, and we end up really not gaining many of the benefits of federated identity. But that being said, it's a positive step forward, and it's a required component of agile access control. Next element is federated attributes. We'll spend some time talking about what we mean by that. Environmental context, we need to have an ability to examine and analyze environmental attributes to apply policy. The resource attributes, what are the objects we are trying to access and what are their attributes? We've seen a lot in the big data world. We're talking about tagging data. Well, those tags would be considered resource attributes. What is the operation or action that I'm trying to perform? Your typical read, write, execute. And then, of course, the ability to apply reusable policy. We want to be able to write policy that's applicable across applications, not one policy per application, which creates policy sprawl and really doesn't provide the value that we would want to get out of that. And that all leads to, what we want to call agile access decisions. Like I said, if attributes are really what's granting access, we've got to work with our local object owners to tease out any of the issues from a political or procedural issue that may create. One other element that's not on this slide that we would be remiss if we didn't discuss is that while these are the elements that let us apply policy, make policy decisions, we do need trust frameworks to make all this work. If we're dealing with federated identity, we're dealing with federated attributes, and if we're dealing with federated policy, we've got to have a trust framework that allows us to base decisions on attributes and identities that are not in our control. And that is one of the ways we can resolve this shift of local object ownership to ABAC. So I don't want to undersell the importance of a trust fabric to really tie all this together. So this is the last slide for me until we get into the vendor. Like I said, we do absolutely need a trust framework to be established, or trust frameworks to be established to make sure we have controlled identities and attributes. We require policy lifecycle management, programmatic and technical management. Business process engineering is key. This is a complete shift in how authorization is managed. We require portability, confidence, and trusted attributes. Need to provide access anywhere, whether it's mobility, cloud, what have you. We need to have mission agility, the ability to apply dynamic policy at a level that's not embedded or hard-coded into our software systems. And then we have to have lifecycle governance and risk management upon all of these three elements, since we are no longer able to explicitly determine who has access to what, because we're not explicitly assigning an identity to an object to grant access. In addition, and we'll talk about this at the end of the presentation, this is the technical view. This is what establishes our technical solution and what leads to our vendor discussions. But business process, program management, governance, all still need to be in place. Strong change management. And this isn't the only panacea. We've got to work with security operations, continuous monitoring, and other operational security elements to make sure that we have the entire picture covered. So with that, I will turn it to Jim Rice from Layer 7. And sorry, this is the mapping of the technologies that we're bringing to the table today and where they play in this pyramid. And I'll let the vendors talk in detail about their solutions. So, Jim?
Great. Thank you very much. So for those not familiar with Layer 7, we wanted to provide a very high-level overview of the technology and how it fits into this challenge of attribute-based and policy-based access control. Historically, the company created its product focused on XML processing, but over the last decade, we've advanced the technology to address a number of different challenges. The gateways or application firewall type technologies that Layer 7 brings to bear in this new era are concentrating on APIs as the new term for what in the past was referred to as web services. So as you can see in the diagram, whether you start with things that are outside your organization that you need to integrate with or across divisional boundaries, providing a control point to what's coming and going across that boundary. The application and API gateways provide a policy-based approach to that, enforcing those rules. External developers are needing to have access to these open data APIs that organizations are exposing out on the internet. A lot of government agencies are following the President Obama mandate of open data, open access, and therefore have developer forums for getting access to government public data. And so these forums need to have controls around who's getting access to that data and tracking the API's utilization. Mobile applications, as we all are seeing a major shift, workers want to be able to do their tasking anywhere, anytime, not just at their desk, which enables tablets and smartphones and other devices to be able to leverage those systems and data of the past. Coupled with the cloud and various other things such as streaming media and or tactical environments, the need for enabling access to these different systems and data, again, without hard coding this into the application, has become the major shift that we're seeing. So enterprises are exposing more of their systems out to others, and to kind of walk down some of the challenges there on the left-hand side, the hybrid enterprise is basically the same enterprise as yesteryear, but now they're having to expose, as depicted on the red arrows there, access to a variety of different channels of getting to that information. So protecting them from threats. Believe it or not, there's a lot of cyber attacks going on out there. It's in the news every day. And so we need to continue to protect these APIs from attack from the outside. Reuse of information. Basically, you start to see an application data set being exposed to one organization or one set of applications, and then there's another set that would like to have access to that data as well. An example of that, one of our customers, GoArmy.com, started out with the recruiting process and quickly saw a need for exposing the same data to different communities outside on the internet. And so rather than rebuilding new apps and new APIs for each new community, they repurposed and reused their existing APIs. Integration is basically made simpler because you have the gateway controlling different data and protocol formats, federation of security, performance optimization. The gateway technology can bring protocol compression and caching all to bear so that the interaction of the user and those outside the organization are getting a better response time and a better user experience. Couple that with different notification services that we're starting to see being pushing alerts out to mobile devices when certain things happen instead of polling, and then finally centralizing the governance of these policies and security so that you have a repeatable solution that doesn't require as much time to go through IA approvals and rolling out to production environments. One example, a customer was able to reduce their IA review times from 13 weeks to 2 weeks per turn, not changing the process, but just moving to a policy-based approach and eliminating the hard coding of the rules into the application logic. So what we have here, in just again for a high-level review, policy in Layer 7 can be categorized into these 4 buckets. One is in the top left, you have API integration, so whether it's inbound messages that need to be secured, or you want to transform the inbound message to support different versions of external user communities that may not have upgraded to the latest API versions. Transforming those messages in real time as they come across the wire into the inbound systems allows you to keep one set of applications or a smaller set of applications up and running in production, but supporting a larger number of versions out in the user community. Traffic control, content-based routing, throttling, these are all different ways of integrating the gateway into the various aspects of the systems. This all plays into a policy-based and attribute-based access control model in that as you expose that data out to others to use, you're going to need these kind of features to be something easily reconfigure. Moving over to identity and access control, you can see Layer 7 supports a variety of standards in the industry, whether it's SAML, OAuth, OpenID, XACML. These are all different standards-based ways, as well as support for integration with legacy identity suites from various vendors. Finally, the last 2 areas, API Service Manager provides a mechanism for you to track the health of who's doing what and when with your APIs. This can also feed into an IA strategy of making sure that if certain users are now abusing your APIs, you have a mechanism for detecting that earlier than we would have had in the past. Also, performance, green, yellow, red status about who's doing what from an SLA perspective of performance of the APIs as opposed to the performance of the servers and the networks and the databases. And then finally, as I mentioned earlier, the developer community, as we onboard developers to use these APIs, there may be various plans, bronze, silver, gold, that are going to be enabling these communities of users of developers to use these APIs, with the ability to explore the API, its documentation, see how APIs are ranking in comparison to others, doing analytics, and then having a forum where developers can interact with each other, whether they're the creator of the API or a consumer of the API. Now, given all that, we have a pretty common reference implementation. It's an architecture that was developed by the DoD and the intelligence community for the last 5 years or more. And it's the notion of intercepting traffic between a service consumer and a service provider. And so this notion of a policy enforcement point is predominantly what the gateway provides. And again, by redirecting the inbound requests through a policy enforcement point, we can provide isolation and an ability to do things to the message before they're actually delivered to the service provider. Likewise, when the response is going back to the consumer, again, policy can be applied perhaps to redact information out of the payload based on their identity or what their entitlements are. All of this being done at runtime without having to modify the application on the back end. What you see below the policy enforcement point is this notion of integration with other folks who are participating in today's call, whether it's a internal PDP or a standards-based commercial product such as that from Axiomatics, attribute retrievals, such as that from Radiant Logic, and then also with risk-based policy decisioning on attributes based on perhaps Sailpoint. So with that, I'm going to hand it over to Dieter to take on the next part of the discussion.
Great, thanks, Jim. So you know, as you guys have probably determined, one of the keys to attribute-based access control is having access to the attributes. And what we've typically seen, you know, the typical challenges across complex environments is these attributes for both the identities that want access to these resources as well as the resources themselves are scattered across different silos. So how do you connect to each of those silos, understand the objects and relationships that exist there, pull that all together in a meaningful way and rationalize it, and then deliver those attributes at the speed and reliability of a directory so that you have, from a XACML policy and administration perspective, a policy information point, or what the FICAM initiative calls an authoritative attribute exchange service. And what we've seen as we've done a lot of these deployments both in the government and intelligence community as well as in the commercial spaces, there's a series of challenges that you have to overcome, and one of the most effective ways to address this is to virtualize what is there. Radiant has been historically known as a virtual directory vendor. We've evolved the platform to become what we call a federated identity service, and the idea is to be able to connect to all of these different sources of information and attributes, rationalize those, and then expose them and serve them up to consumers via various protocols, various schemas, various structures. So I'm going to take a few minutes and I'm just going to start to break down what has to happen in order to build this federated identity service. One of the key things that we found is as you look into all of these different silos, it's often very difficult to identify the same object across these silos. So as an example, if I'm working with users, it's entirely possible that I might have the same users, but they have different identifiers in different systems. In order for me to create a composite profile, or in order for me to create a meaningful hierarchy that you can navigate through and understand the context for each user, you need to be able to understand that I have the same users, but they have different identifiers. I have to tie those different identifiers to the user, and then I can use that to be able to navigate into each one of these silos and understand more about that user in the context of that given silo. Right? The other side of that is that I might have the same identifier, but it belongs to different users, and I certainly don't want to use that as a way to perhaps join or build a composite profile across the users, because I'm bringing attributes from different users into the same profile, and that's bad. This is important for generating a complete list of users. This is important for in cases where you want to effectively route authentication to appropriate backends, but this is also very important for joining and creating that composite profile. And one of the things that we've seen too is as you start to join the data across these different systems, joins are very expensive. And so the only way to viably deliver a composite profile where you're joining very large numbers of users and a number of different data systems and to deliver that at the performance and speed of a directory is to cache that into a directory. And caching requires that you have the ability to understand what has changed in these back-end systems at a granular level and to be able to apply those changes to the appropriate place in the cache. So it's more than just aggregation, it's also correlation, it's integration, it's the ability to detect changes from these different systems and in a smart way synchronize that into a cache, and then the ability to build consumer-specific views because various applications have different requirements for protocol. Some want LDAP, some want SQL, some want web services or REST services. And then also to be able to deliver the schema and structure, and in many cases the data, in the way that the application wants to consume it. And while we talk about attribute-based access control, one of the things that we continually see is that many of the applications that want to consume this data are still based on groups or roles, at least at a high level, so you have to be able to build the groups and the roles that match the needs of the applications as well. Often those groups or roles can be built based on attributes. So if we take a look at the next slide, I'm going to show you just a simple, tangible example of how this can be done. And in this case, we're looking at a policy decision or policy enforcement point, as well as a policy administration point as a consumer. We have the Radiant One VDS as the attribute server. We're connected to 3 different backend systems, an Active Directory, an LDAP directory, and an HR database. We've used attributes in these different systems to identify that it's the same person across these different systems. So we're looking, in the case of the connection between Active Directory and the LDAP directory, at perhaps first name and last name, and maybe some additional attributes like department number to determine that this is in fact the same person. Between the LDAP directory and the HR database, we might be using employee number or some number of other attributes. And once we've made that connection, we can create that composite profile that you see on the upper left-hand corner. So we see now that for Andrew Fuller, we know that his title is coming from the LDAP directory. We know that, bear with me here just a second. We know that his male attribute is coming from Active Directory, and we know that his department and his region is coming from the HR database. So not only do we have a composite profile that you see in the upper left-hand corner, but we also have the ability to create dynamic groups based on attribute values. So we can combine, for example, clearance level, title, and region, and come up with groups that are predefined based on unique values in that combination of attributes. And now we can search for the user and see what groups that user is part of, or we can search at the group and see what members are part of that group. And this is important not only at the time that you're evaluating the policy, but it's also very important at the time that you're defining and administering the policy, because if you have access to all of the data at policy administration time, it's a lot easier to start to understand what you're securing and how you're securing it. So with that, I'll turn it over to Gerry Gebel, and we'll talk more about the policy decision point, policy enforcement point, and policy access point.
All right. Thanks very much, Dieter. At Axiomatics, we operate in part of the identity management market that Gartner refers to as externalized authorization managers. And what I wanted to do is explain in a little bit more detail some of these different architectural components in an ABAC or a policy-based access control system. Now, you might recognize some of this terminology and icons from the XACML or Extensible Access Control Markup Language reference architecture, and that is the basis for what we're discussing here. So from the first aspect is the policy enforcement point, and as Jim mentioned, this is a piece of code that sits in the transaction flow. Commonly, it is a gateway, an API. It could be another type of enforcement point as well, and so it interrupts the flow, captures what's happening, the user context, excuse me, and so on, and formulates a request to a policy service. We click once more here. The next major component is the PDP or policy decision point. This is the main rules engine of the system, and this will come up if you click one more time on this slide. Thank you. What's important here is a couple of things. One is that you have externalized the authorization process from the applications so that you can manage it in a more centralized and consistent manner. But this system needs information. It lives on attributes. As Dieter so elegantly pointed out, attributes can be resident in many different locations. And so to consolidate and aggregate that data is a very powerful concept, and in this architecture it connects through what we call the policy information point. One of the additional benefits that I wanted to highlight that Dieter mentioned is the fact that the virtualization layer in Radiant 1 can surface relationships between objects that are not there, that are not present if you're accessing just one directory by itself. So that's a very powerful concept and gives additional leverage in your access control model, because the policies can utilize that advanced information to make more complex or more granular decisions. And then finally at the bottom here we have the policy administration functionality. So this would be the product features that are creating policies, managing their distribution into the development, tests, QA, and production environments, monitoring the overall system. And in our case, the policy language is the example policy language, and this is what it gives you the standard-based approach, gives you an opportunity for interoperability and vendor choice, but it's also a reusable policy across different aspects of your application architecture, and we'll see that in a moment. But I also wanted to point out that the policy language here it's much easier to use the policy language to represent your business and security rules than it is to try to do that with the older structures that are more static, like roles or group lists. And we'll see that in some of the scenarios that come up toward the end of the presentation. So if we go to the next slide and take this architecture and apply it to a typical application structure. Applications are not monolithic anymore. It seems that there are all kinds of mashups between presentation or portal layers in one place, service bus, or other kinds of business tier logic APIs, and then of course the data tier. And the idea that we're trying to reinforce here is that you can put your enforcement points at different layers of the application, because the enforcement points are specific to their environment, whether it's at the presentation layer, at the API layer, down at the database tier. And the notion here is that you can get a consistent level of enforcement across this kind of application environment, and also to apply the security at the right level where you have the context available about the user, about the action, and about the resource they're attempting to act on. Furthermore, this kind of architecture has additional benefits for scalability and other operational considerations. So you can replicate the number of PDTs in the environment. You can scale these systems up to hundreds of millions of users, as we've seen in production. And they also can be architected or configured for high availability, for global operations, and 100% uptime, which is, of course, of critical importance. And then my last slide is the next one here, taking yet another view of this architecture and applying it to on-premise, cloud, or hybrid scenarios. So the idea here is that you can place the enforcement at or near the application or as a shared service. And the same thing for the policy decision service. It can be a shared service or it can be located close to the applications or resources, again, depending on your needs for performance, response time, scale, and availability. So this gives you a lot of flexible deployment options. So now it's easier to move your workloads to the most efficient computing platform, which is just not possible or extremely difficult if you have your authorization hardwired to your local infrastructure or embedded completely into your application. So this also enables you to integrate SaaS applications into your on-premise or legacy environment, and gives you, again, a lot more flexibility as business conditions change rapidly. You want your IT or your authorization infrastructure to be able to adapt quickly to that as well. Now I want to tee it up for Phil McQuitty of Sailpoint here to talk about attribute governance, because as we've been saying all along here, attributes are key, and so the quality of those attributes are extremely important to the runtime environment. So Phil, please tell us all about that.
Thank you, Gerry. So let me use 3 slides here to quickly cover that message. And the first one here, Sailpoint architecture, I just want to reference the primary modules and key capabilities that we address in a larger scope, and then we'll address the question particularly in this access or attribute and policy-based access environment. The main modules within Identity IQ, which is the name of the solution, are listed at the top. Compliance management, that really is everything to do with answering the question of who has access to what, and is that access appropriate? And so that's a set of business-friendly screens that let people look at the access that individuals have. Access request and provisioning is your traditional request and provisioning fulfillment for the enterprise. Password management, so self-service password reset, password synchronization, all those traditional capabilities are in that module. Single sign-on is a capability we provide along the way for web and on-premise web as well as cloud-based apps. And then a mature identity analytics interface. And again, all of these interfaces are designed for use by the business as opposed to the IT team. And so the identity analytics, again, just gives you a different set of perspectives on identities, their access, their apparent risk to the enterprise based on potential anomalies of access. And so it's a tremendous set of components there. They all reside and exploit this common layer listed in the middle. So there's a policy engine that can detect anomalies in access rights. There's a role model that lets you group and collect, in a traditional sense, the access permissions that are associated with a protected resource. And in this attribute discussion, we're able to create a persistent, viewable model of those attributes in order to show the policies that Gerry just described in terms of runtime dynamic access. But we're able to label users with these roles so that you can see who's got access to what, once again, in the attribute-driven model. The identity warehouse, that's our data store. Our risk model is interesting in terms of showing a risk and calibrating the risk that any given user or application presents to the enterprise. So that it's pretty obvious the notion of a risk score for an identity, but we also calculate a risk score for applications. So if an application has a load or an unreasonable number of orphaned accounts or high-risk users, the application may present a risk that you want more visibility into. And then there are numerous transactions coming out of all this analysis and identity management that we're doing, and there are times when we need to touch the enterprise systems to revoke access, to grant access. So we have a mature set of connectors that allow you to do that. So on the next slide, really in terms of this conversation around attribute-driven access control, policy-driven access control, we at Sailpoint specialize in answering that question of who has access to what, and is that access appropriate? And that question is very interesting in this model, because the equation of who has access to what is never resolved until an individual clicks on some element in the IT infrastructure and tries to access it. So who has access? We understand the nature of those that can access this, but seeing a traditional list of people who do have access, who are those people that meet the attribute composition required to access this resource? And that's where Sailpoint steps in, and we're able to to provide that traditional view of access right, who has access to these protected resources. So it's a beautiful marriage between allowing this dynamic access paradigm and combining that through Sailpoint's offering to provide the traditional views and management of those attributes. So these questions over here to the right are where we live. Who owns the attributes? What are the relationships between them? And how do we model those attributes so that the business can make sense of them and review them, review who has them, and how do we manage that process of changing those attributes? Who can change them? Who needs to approve those changes? And what's the life cycle of those attributes? So if attributes are the driving element behind who gets access to what, the integrity of those attributes is key. And that's where we live. So if you go to the next slide, we'll close with this concept of, and just advance that slide one more time. I'm not showing the slide advancing, so possibly I've paused. But in essence, the next slide in my presentation just shows a traditional cycle of business process that we bring to the table where we are looking at the ownership of those attributes, the change management of those attributes, the policies around who needs to approve those attributes. So really providing that traditional flow of business process around maintaining the attribute base. And with that, I'm going to turn it back to Paul Grassi of Sila. And Paul, take it away.
Thanks, Bill. So you guys can read this on your own, and we'll be sending these materials out. But there's a significant amount of benefits to this type of solution, this type of approach. I'll just summarize them, kind of working my way from top right corner clockwise around. Policy management and insight available to all levels of the organization. What do we mean there? We've taken authorization, policy making out of the hands of developers and elevated it to folks across the organization that have real skin in the game. It could be your privacy office, it could be a regulatory body, it could be audit, really is participating in the end-to-end process of applying policy to data. And one thing that I don't think we really mentioned a lot, and the NIST document talks about this, it's really our ability to codify natural language policy in a way that makes sense to these business owners that are actually defining that type of natural language policy. Maybe one day we'll get there where we can just type in English language and out comes a policy. But for now, with this tool set or set of tools, we're at least able to engage our stakeholders in a much more meaningful way. Instead of a trust but verify, they're a participant in policy making controls that are applied at the technical level throughout a typical life cycle. We've improved operational efficiency. The traditional benefit of identity management, I think, is amplified here. Rather than lengthy workflows, whether they be automated or manual, we are now dealing with near real-time access, even to the unanticipated user, based on trusted attributes. From a deployment perspective, on the operational side, we're not coding anymore. We're applying, as Gerry talked about, policy enforcement at multiple layers without inserting a lot of code. So change management is a lot easier. And again, we're dealing with natural language policy, so we're including policymakers in a part of the O&M cycle that they normally wouldn't be part of. With utopia being as policy changes, due to regulatory issues or environmental issues, these analysts can actually apply policy changes without needing IT. And then performance is, of course, an issue. We're extremely scalable. We can apply policy at various points in the infrastructure. We can apply caching techniques across the board so that we're not dealing with latency. As you've seen, there's a lot of moving parts that dynamically query and dynamically apply controls, yet we have the flexibility to make that information available based on your performance needs. And then finally, and one thing that I don't think we've really honed in on, we are one of the only pure play interoperable solutions, which would be pure XACML across all layers, and then your standard REST, SOAP, WS security, LDAP type interfaces to not only get into this environment but also query attributes. And that allows us a lot of flexibility and pluggability within our architecture. So, just a quick summary of the beginning part, and then we'll get into the deck or into the use cases. How does this change things? We saw the frustration of users. Now we've got a user that comes through the front door with their credentials, with their attributes already attached to them. This is that notion that I think Gartner, Ian Glazer might have coined, that identity is the next firewall. I am coming in with the attribute or entitlement granting attributes at the front door. And this doesn't, I know this is a PIV card which infers strong level of assurance. This isn't a strong level of assurance solution only. It's applicable at all levels. There's some models out there in the private sector with OpenID where attributes are asserted on behalf of a user from places like Google. It's really about the amount of risk associated with the data that we are applying. Some of these attributes, on the low level of assurance side can be self-asserted. But on the higher level, that's where we get into, the trust frameworks and the strong governance control that Phil talked about. So now when I'm through that front door, there's no more frustration. The doors that should be opened are opened. The doors that should be closed are closed. And I have immediate access to the information I need to do my job. Okay, next slide. So let's drill into use cases. We struggled with, what use case do we select? We know we have a lot of industries represented on the phone call. We're very thankful for that. And obviously, we think that this type of solution is applicable to a lot of different business domains. We chose healthcare because that's what the 800-162 document uses as its primary example, not because we are favored towards this type of environment. And we anticipate in future webinars we'll drill into multiple domains, whether it be financial services, intelligence, defense, information sharing. So this is not obviously the only one, but we thought there was a rich set of use cases across organization boundaries, across actors to fully demonstrate the baseline capabilities that we want to get across here. So, kind of working around from the patient counterclockwise, the patient's managing their own personal record in some sort of patient portal that can be provider provided. It could be something like Microsoft Health Vault, and they're managing information that they're allowed to manage. They're taking their own blood pressure, they're monitoring their pulse, they're monitoring their weight. In that same portal, or perhaps in an information exchange between hospital networks, that patient is opting in to share his health information, his or her health information. In this case, they're authorizing their primary care physician to view the patient portal information. And we're assuming that this opt-in authorization follows legal and regulatory guidelines around how binding it needs to be. So we'll assume it's an electronically applied digital signature in this case. And then one other note that the patient is accessing this only from authorized personal devices. So a random computer in a random location to protect against any type of fraud would not be allowed to update this record, even if they authenticate with the right credentials. The doctor can read from his or her office computer, and as you would expect, can write to the entire health record and can view the entire health record, including history. The nurse is a little bit different, can only write demographic information, symptoms, vital signs, but can't get into clinical updates without authorization from the doctor. And in this case, we are excluding this nurse from doing that. However, there is a scenario where we can break the glass. There is a location agnostic emergency that needs to be accounted for. So while the nurse may be in a location that, in a typical environment, and by location, maybe they're in cardiology and they need to be updating oncology information. Normally, we wouldn't allow that type of update, but in a break-the-glass scenario, in a time-boxed manner, we allow access. Health service has been completed. A receptionist trained in HIPAA data protection can only view services performed in order to document the right information for the insurance claim. The claims coordinator can only view appointment information, and there's some more rules will apply as we drill in. And then to kind of close it out, we've got an R&D organization that can only read anonymized cardiac clinical data from hospitals and patients that opt in. So even though it's anonymized, we have 2 opt-ins here that must be applied before an organization can pull this information for research purposes. So what's the architecture? I'll go quick on this because you've seen this. We're going to, in most of these use cases, we're going to assume that Layer 7 is acting as the secure gateway. It's providing the policy enforcement that we require. But as you'll see further on down the road, we are pluggable. So it doesn't necessarily have to be this way, but in the solution that we're presenting, we like them up front, given the way they're nimbly apply security controls and policy enforcement beyond just XACML-based permit deny. For completeness, we plugged in authentication services just so you know that we have that critical ability to consume multiple credentials, but we aren't providing that service. We are allowing that to be hosted elsewhere. Policy Axiomatics is serving as the PDP and the policy administration point. Radiant Logic is the federated identity view and virtualization. And what you'll see in there is not most likely we won't create this uber singular directory with all doctors, patients, nurses, insurance companies jammed into one physical directory. We slice and dice that and provide virtual views based on functional need. And then we can dynamically serve that up. So we may have under the hood a patient view and a provider view that's viewable by a doctor's office, but an R&D organization is only presented their own specific type of view. And we've done that without changing the underlying authoritative sources, the underlying correlation rules, and the underlying physical schema. Then we have all of our attribute sources, authoritative, and then of course governance that Sailpoint would provide across this entire environment, and the system itself. And there's a line missing here. We did it on purpose, but there's nothing to say that an EHR system, or any application for that matter, can't go directly at the Radiant Logic store as well. We are not saying in this architecture that the policy information point is for only policy decision making. It can be as a way to query attributes from any type of consumer, whether they're a functional application or a policy decision point, it doesn't matter to us. Those views are available and customizable based on need. Okay, so in this case, we'll walk through. The patient is attempting to access their own personal record. Layer 7 will intercept that. It checks the validity of the requests. It looks at the underlying protocols and security of those protocols. And it's making a request to Axiomatics to permit or deny this action. Axiomatics does two things. It looks at, it tries to determine if this is coming from a valid device, and it also needs to be that this patient is trying to update their own record, not somebody else's. So, the policy target is inspecting what the request is, what the target is, what the operation is. It's using Radiant Logic to query the list of registered devices, and it's using its policy to determine that, yes, this patient is, of course, trying to update their own record. It returns a permit, and Layer 7 dutifully abides by that decision provided by Axiomatics. According to standards, it can't do anything else but to follow that advice, and the user is allowed to directly update blood pressure in their system. And what they'll also do, which is key here, is they're signing their opt-in forms. This is functionality provided directly by the application. So what's interesting here is I'm directly updating and providing authorization information into the application. Later on down the road, the policy information point will then be the one that ultimately queries that information for me to determine if this record is in fact viewable electronically by a doctor. So the doctor use case follows a very similar flow. The difference here is what policies are being applied and what the policy enforcement point is doing. You can see here that Layer 7 is doing very similar work as it did for the patient. The addition here is it's checking directly if this is accessing from an office computer. It doesn't need to go to Axiomatics to make that decision. So when we talk about flexibility, when we talk about performance, we look at policy. It doesn't necessarily have to be policy that's always enforced by Axiomatics. We have some flexibility here to do this type of check at the Layer 7 level. Layer 7 determines that it's from an office computer, and then it moves the rest of the heavy policy decisioning to Axiomatics. What Axiomatics does is then use Radiant Logic, as I discussed. Radiant Logic will query this opt-in repository, and sure enough, this patient has opted in. The doctor is allowed to use this information as part of clinical care. Axiomatics applies the policy. Policy comes back as a permit, and the doctor is allowed to perform the care that they are required. We started to find, and this is what I think is good about this architecture, is the flow was pretty much the same based on any type of use case you looked at. What changes is the type of policy you apply. What changes is the authoritative sources for the information. And then there's some design decisions that you'll make in terms of where you want to apply policy. Like I said, all this material will be provided to you at a later date, so you can read through this yourselves. But what I wanted to highlight here, and I want to be able to get to your questions, is in the R&D bucket, we decided to apply PEPs in two places. We've got the typical PEP at the Layer 7 level that's doing all the web service-based security work. It's authenticating the R&D server. We're assuming that this is a batch type of process. We're not dealing with a human per se. So we have some mutual SSL or some other type of security authentication going on here that Layer 7 is handling. It is making a call out to the PDP, looking for things like hospital and patient opt-in. But then we've also applied a SQL data level PEP at the Axiomatics level. And that's what's really responsible for filtering out the information that is allowed to be returned back to this particular research organization. Again, just another example of flexibility, another example of our ability to push policy enforcement to various layers in the architecture based on performance, based on what makes sense, based on what is more secure. And in this case, we thought it was more applicable to pull the right data out of the database as opposed to pull everything and expect some other third party or even the layer 7 tool to filter that result down. We keep data that's not allowed to be seen inside the data tier so it doesn't move. Great, and then we close here with the governance. You've seen this in some respect with the slides that Phil presented. The takeaway here is that audit is very hard in this type of environment. This is a paradigm shift. It is very computationally intensive to now know who really has access to what, because an attribute of top secret security clearance or medical professional or job role doesn't really provide the information that I need to know on who has access to what, like we have in the traditional model of ABAC, group assignment, or ACLs. So it's important to have governance and strong controls for attribute review. It's very hard to determine which attributes grant access. As I talked about earlier, we are kind of sliding the scale of authorization ownership away from the local admin and down to really the attribute authoritative source. The local admin still is going to say this type of attribute combination gets access to my information, but they really don't know who will get that. So there's a little bit of a paradigm shift. So what Identity IQ gives us the ability to do is put strong business-friendly compliance reviews on top of attributes so that we can ensure that the appropriate attribute value or values is assigned to the people, the subjects working within our organization. And then we also have some capability to do policy review itself through the Axiomatics policy auditor, so that we make sure that we're not creating conflicting policy, so that we have at least an administrative lens into what our policies are doing so we don't create conflicts across our multiple policy sets. So this is our last slide, and then we'll get to questions. I think we've left ourselves the right amount of time. I've mentioned, this is the typical consulting slide. It's not all about technology. You have to have governance. Given everything we've all said, this is a paradigm shift. It is creating new functional organizations, business organizations inside of your enterprise to make this work. You have to choose your standards, determine your attributes and metadata, determine your authoritative sources, create a taxonomy. It gets exponentially more important as you're dealing with information sharing partners that may not share the same data definitions that you do. So we need to be very careful here, because a attribute of job role A in your organization may provide access to objects X and Y. That same job role in another organization may be X, Y, Z. You don't want to expose that type of risk to your organization by assuming that values that are the same actually intrinsically mean the same thing as it relates to authorization. Business processes will completely change. We obviously can't apply this globally, so we need to develop a business case for this. This is not for legacy applications. This is not a boil the ocean. We don't want to deploy this across the organization, across all IT platforms, so we need to pick our targets wisely. Last I know, a Unix system, file system control isn't shifting to a XACML-based model quite yet. We hope they do, but you will still need to maintain your existing provisioning systems, your existing provisioning workflows, your traditional who has access to what, because we're not going to globally apply. Policy management, who's going to own that, the change management of it, the definition of it. That's a part of governance as well, but we wanted to call that out. Your stakeholders and the visibility and transparency they have into environment will grow, so coordinate with them, and then track performance, which is kind of the mantra of the day. If it doesn't get measured, it doesn't get done. So without further ado, we will move to questions. I think Alex, as our host, has been collecting questions. Alex, are you there?
This one. Post it up in the chat.
Okay, so we have a question. I'll target this to Gerry. Are you starting to see support for XACML and commercial tools such as SharePoint or ERP tools like SAP?
Well, yes and no. So in SharePoint, certainly they have the claims-based model with SharePoint 2010 and later, and we've developed a capability to actually translate XACML policies into the resource and user claims such that SharePoint can enforce them internally. But the convenient part of this, or the important aspect, is that the policies are defined outside of that particular platform. Now, SAP is heavily built on a role-based model, so and it's very much ingrained into the application itself. So the ability to externalize authorization is more difficult with an ERP system like SAP, and we can only hope that from customer pressure they open that up more over time. Another example to point out, though, is EMC, is building XACML into their new platform for applications like Documentum content management. So EMC has been very active on the XACML technical committee, and like I said, building that into their platform. So we're seeing some movement here, but certainly would be great to have more.
Great. I forgot another question. You mentioned unanticipated user. Tell me how this solution can apply to an unanticipated user. And I think Jim will take this.
Yeah, I'll at least start answering, and then maybe others on the call, on the team here for today's presenters can chime in with complementary data. But one of the things that many of us did in the past 3 years was participate in a use case that came about as a result of Katrina, where you had Homeland Security, FEMA, Coast Guard, NORTHCOM, which is a military organization, .mil, and first responders all showing up at a Katrina-type event, all wanting to have access to various systems and data that may or not be theirs to access. But yet they needed the information such as, where's the deepest parts of the Mississippi as of yesterday, because all markers as to where that information was, may not necessarily be the same today. And so there was a need to share information across system organizational boundaries, and yet who do we trust in order to allow these unanticipated users to have access? So that led to a R&D activity with Homeland Security, Science and Technology that was the beginnings of this ABAC policy-based access control pilot, which led to the extension of SAML with a extension called Back-end Attribute Exchange Profile. And so we vendors on this call have participated in standing up support for that standard and enabling the use of access to a back-end attribute exchange gateway protocol so that you could have trust established between organizations in advance, that when an unanticipated user from organization X shows up, you could go to that organization's BAE gateway, ask for information about the individual, and then apply that into the policies of whether to provide access or not to someone that you may or may not know. So that's one aspect. Others are utilizing this concept in a visitor system scenario where employees of agency X want to have access to agency Y from a visitor center perspective. A lot of times you have to send your credentials in advance so that the guard at the gate will permit you to have access to the building. It's a paper-based system in many cases or email-based, and so automating that can leverage the same BAE profile. So that's one quick response to unanticipated users and how an ABAC, PBAC approach can be applied. I don't know if anybody else from the team wants to chime in with anything else there. We're seeing more questions come in.
Okay, the next question. What are the benefits of an RBAC, ABAC hybrid solution, and what standards are available in this space?
Paul, do you want me to take that one?
Sure.
Yeah, so the ABAC side of this, the standard question here is, of course, XAML, the Extensible Access Control Markup Language, is an example of an ABAC standard. The benefit of combining that with a role-based system is that you can add so much context to the role without having to define additional role entities. I can take a role like a doctor or a cardiology nurse, or a nurse, and I can apply additional context like cardiology, oncology, pediatrics to that without having to create these additional roles. That's the key benefit here. It gives you a lot more flexibility. It's a lot more scalable from a policy authoring perspective, and it also mirrors the business rules you're trying to implement. You know, it's not that I need to put someone in the role of doctor, but what other characteristics about them do I need to implement in the policy-based system?
Thank you, Gerry. We've got another question. Is there a concern about performance of the system when introducing an externalized authorization solution? And I think more to the point, what are the approaches to make this solution performant as we shift from local authorization to externalized authorization?
Mm-hmm. I can take that one as well, Paul.
Yeah, okay. Thanks, Gerry. I was going to chime in as well, but maybe you'll just hit on what you and I are doing.
Absolutely. Yeah, so there's certainly a concern about performance in any system design. And what we look at in an ABAC model is two key areas. One is the communication between the enforcement layer and the decisioning engine. So if you're going over a slow protocol, obviously that's going to impact performance. So there are options to use a faster protocol such as Apache Thrift, but you could also co-locate the decision engine with the enforcement and application layer. So as Jim was just alluding to, with layer 7 and Axiomatics, we can co-locate the decision and enforcement layers so they're doing in-memory calls and there's no over-the-network latency introduced. So that's a really fast way to configure the system. The second area to look at is in attribute retrieval. You know, these systems live on attributes. If the attributes do not come in with the request, then we need to look them up in their source locations. But having the Radiant Logic virtual directory in place, the ability to aggregate and even cache that information local to the decision service, again, is a great benefit to performance. So as you mentioned, Paul, it's really about looking at the different ways of addressing the performance concerns of the particular system, and there are many ways to that. There's other caching ways of addressing this. Back to you, Paul, or Jim, unless you wanted to add anything more to that.
No, we, again, leveraging standards, we initially worked with Axiomatics at layer 7 and other XACML engines using the standard request response protocol. But then due to scalability in certain use cases, we saw the need to bring the PDP closer to the gateway. And so as Gerry talked about, one of the deployment options is for customers to co-locate the PDP engine with the PDP gateway so that there's no chatter over the network.
Dieter, you mentioned briefly performance in your deck. Anything you wanted to add to this?
No, I think Gerry really hit on the key point, which is part of the success of this from a performance perspective is being able to get the attributes at the speed of a directory. And so if you have the attributes scattered across different systems that need to be accessed to a web service or through other protocols that aren't necessarily fast, highly available, or reliable, really the only way to address that is to cache at the policy information point level, and that's one of the key values that I think Radiant provides.
Thank you so much. That concludes all of the questions. And just as a reminder, we're going to be sending out a recorded version of the webinar along with the slides from today's webinar by tomorrow morning. And also a survey will be included. So if you could please fill that out, that would be much appreciated. So thank you so much for joining us. We really appreciate it. And that's all.